My name is Jonathan Paparo. This is the Physics 2212 Lab 2 on lines of charge. The introduction. Today we will observe the interactions of charged pieces of tape and determine the charge of the tape and number of electrons. And we will use glow script code to simulate the interactions between the electrons of the tape and other objects, specifically the difference between a point charge and a line charge, and yeah, how that data differs from each other. The results were that the two pieces of charged tape repel each other, and the estimated charge on the tape is 1.534 e to the negative eighth coulombs. Another part of the introduction, the purpose is to determine the charge on one piece of clear tape, and we'll be performing these calculations by treating each piece of charged tape as a line charge, which is more accurate than treating it as a point charge, because it is more directional. Physics principles used are the electric field the force of the electric field is the electric field times Q, which is the charge, and then Coulomb's law to find the magnitude of the electric field. Yep. And F equals ma so that we can set the force of the electric force equal to the force of gravity. Uh, This is the model. The tape mass was 1.8 e to the negative fourth kilograms, and the tape was 0.018 meters long, and its width was a given amount of 0.02 meters. Right. The electric charge on one piece of tape was 2.94 e to the negative eighth, and the gravitational force was 1.764 e to the negative third. And that's the code that was used to run this. All right. In conclusion, what if you had modeled each of your tapes as a single point charge like in the previous lab and compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model? So the line charge was at 1.53 e to the negative eighth, and the point charge was 2.94 e to the negative eighth. And that's about a 50% difference, and that's because of when you treat it as a line charge, many of the charges that are not directly in the center cancel each other out since it is a symmetrical piece of tape. So that is why it is much lower. And yeah, why do these differ? The line charge, as I just said, is much more accurate than the point charge model when computing the charge of the tape, and this is because it's divided into multiple different segments of point charges at the different locations on the tape, and the more segments the tape is divided into, the more accurate the model would be in predicting the actual charge of the tape. So yeah, you try and create infinitesimally small pieces of tape so that it is perfectly it is a perfect model for what is actually going on with the forces in the tape. All right. And yep, some sources of error in the experiment would be human error from handling the tape or touching any other object and either adding or losing electrons to the tape. And yeah, the mass of the tape was also just an estimate entirely. We really actually did not measure the mass of the tape. And yeah, there are other forces that could have been accounted for that were not accounted for. So the F equals ma wasn't entirely correct, setting the force of the electric field and the gravitational force equal to each other wasn't exactly correct. So that could also lead to some sources of error. All right, thank you. Give me a 100, please.